Right, first of all, what is an asymptote, right? Let's have a look here. An asymptote is a line that a curve approaches as it heads towards infinity. It approaches the line but doesn't touch it. There's a horizontal asymptote in blue, vertical asymptote, and this is neither horizontal nor vertical, it's oblique. So, back to the question. Asymptotes parallel to the x-axis are found by equating the highest power of x to 0. What does that mean? Asymptotes parallel to the x-axis are found by equating the coefficient of the highest power of x to 0. So we have to play around with this. Y equals x squared plus 2x minus 3 all over x squared minus 5x minus 6. So I'm just reading this here again. Asymptotes parallel to the x-axis are found by equating the coefficient of the highest power of x to 0. Right. I'm going to multiply both sides of this equation by this stuff here in the brackets. So that gives me y times x squared minus 5x minus 6 equals x squared plus 2x minus 3. Right, the highest power of x there is x squared. Now if we multiply in the y here, we get y times x squared minus 5xy minus 6y equals x squared plus 2x minus 3. Now the highest power of x, equating that to 0, if we subtract x squared from both sides, I'll do that in red, right, minus x squared, that'll make x squared disappear from the right, but I must do the same to the left, so I can shove it in here. Right, I'm going to rewrite that then as yx squared minus x squared minus 5xy minus 6y equals 2x minus 3. Now we can factor out the x squared here from these first two terms or items. So that's x squared times y minus 1, and the rest of the stuff stays the same. Minus 5xy minus 6y equals the stuff on the right hand side. So the highest power, the coefficient of the highest power of x, equating the coefficient of the highest power of x, the coefficient is the bit that stands in front. This, we could read this as y minus 1 in brackets times x squared. So this here is the coefficient of the highest power of x, and we're going to equate that to 0. Right, y minus 1, we're equating that to 0. And if we, so that's y minus 1 equals 0 is the same as y equals 1. And that there is the asymptote. That's the asymptote. Asymptote parallel, if that's spelled right, I'm not even sure, one R that should be, anyway, parallel to x-axis. That's also, of course, our horizontal. So that's our horizontal. That's our horizontal asymptote. Right, so what did we do? We got the coefficient of the highest power of x. So for the vertical asymptote, we're going to get the coefficient of the highest power of y and equate that to 0. So coefficients, asymptotes parallel to the y-axis. So that's asymptotes, that's vertical asymptotes, are found by equating the coefficient of the highest power of y to 0. So in this case, we multiply both sides by the bottom piece or the denominator here, and we'll get x squared minus 5x minus 6 times y equals x squared plus 2x minus 3. So this bit marked here in red that's the coefficient of y. That's the coefficient of the highest power of y, because there's only one y in the whole thing, y to the power of 1. And this is the coefficient of the highest power of y, and we're going to set that to 0 and solve it. So we have x squared minus 5x minus 6 equals 0. Now 1 times minus 6 is minus 6, and minus, how are we going to solve that now? Minus 5 equals minus 6 plus 1, right? And 1 multiplied by minus 6 gives us minus 6. So we can rewrite this as x squared minus 6x plus x minus 6 equals 0. We've rewritten it. Right, now we're going to try and factor out. So on the first two terms here, we can take out x times x squared minus 6, and that should be x. Just back it up there. So that's going to be x times x minus 6. And looking at the second two terms here, if we want x minus 6 in the brackets, we can have plus 1 times x minus 6 equals 0. So this simplifies to x plus 1 multiplied by x minus 6. So that's this top quadratic equation here factored. And now we can say that either x plus 1 equals 0 or x minus 6 equals 0. So x plus 1 equals 0 or x minus 6 equals 0. That should be an x. So that means x equals minus 1 or x equals 6. So these are two lines. These are two vertical lines. Right? X equals minus 1 is a vertical line on the graph. It should be straighter than that, but you get the idea. It goes on and on in both ways forever. And this is another vertical line. And these are asymptotes that the graph approaches but never touches. That's the line x equals 6, and that's the line x equals minus 1. So I've drawn this in Desmos. I'm going to flick over now to have a look at it in Desmos. Right, x equals minus 1. We can draw in that line on here if we want. X equals minus 1. See, that's in green. And x equals 6. X equals 6. That's it there in purple. Those are the two vertical asymptotes. And what did we say the horizontal asymptote was? Y equals 1. We can also draw that in. Y equals 1. Y equals 1. And that's another line the graph approaches here and here without ever touching. So you just have to go through it yourself and have a crack at it.